I think it's time we jump right into it with our first presenter and topic of creating value through secure design for modern apps with Snyk. Presented by Eric, who is a developer advocate for Snyk, and Eric has 25 years of experience in enterprise software developing and architecting. Eric has been a continuous integration advocate and implementing for nearly a decade. Eric, thanks for joining us.
Wow, first up, thanks for the intro.
Yeah, not a problem. Hey, I'm going to pass it off to you. The floor is yours, and we'll rejoin when it's time for Q&A session.
Awesome, thanks so much. So, Eric Smalling, said I'm a developer advocate at Snyk, been there for about a half a year now, and with a background in software development. But since we have quick time today, let me jump right into this with you. So, first of all, let's talk about software delivery lifecycle, or SDLC. As we all know, this is the process of developing and shipping software. And this has changed over the years, as anyone who's been around has seen. Agile practices have accelerated release cycles from a few a year in the old days to, in some cases, multiple times a day. To support this, the culture and team alignments have evolved from the old siloed development teams throwing code over the wall to operations and testers and security teams to audit and run them. But now these teams are more integrated and collaborate more closely to build, test, secure, and run the applications. Unfortunately, while the DevOps movement and advances in the automated testing and CI/CD tooling have enabled this fast pace, AppSec teams are finding it hard to scale to match their speed. A small AppSec team with traditional security tooling is just not fast enough. When they find issues, they cause the development team to have to effectively halt the pipeline to come up with a fix for the problem or figure out what's wrong and implement it. Worse, if the business need is too great for that feature to get out the door, they may actually say ship it with a known vulnerability and let's get it fixed in the next release or something. And that's a security risk, obviously. These traditional security teams and their tools focus on detecting and reporting on vulnerabilities by creating an audit report or something that will end up being a gate in the pipeline, if you will. The successful approach, or the approach we've seen that's most successful, is to enable security to be built in a continuous process, kind of like CI did for development, right? To continuously align with the iterative DevOps model. And the responsibility for security has to be initiated from development, with the application security team acting in a supporting, advising, and governance role for this model to scale. It's a similar model to how the DevOps process evolved, which brings us to, well, actually, let me jump this, sorry. What constitutes an application also has changed before I get into DevSecOps. Application cloud deployment has transformed what traditionally was infrastructure into code, with different needs, ownerships, and responsibilities to secure it. Traditional application security tools focus on finding vulnerabilities in the functional code, the top left block as you see on the slide. Securing the infrastructure as code is often done at runtime, taking a look at what's going on in runtime and applying rules or trying to mitigate at that point. This is treating the cloud infrastructure kind of like we did the old physical infrastructure, right? So in order to scale our infrastructure as code, we really need to be scanning those things before we deploy them, while they're still just code, right? The code that makes up an application also has changed. In order to maintain the pace and to compete with other companies nowadays, application development has transformed in that most of the application that gets deployed is open source code. Now, this increases the speed that we can get things out the door, but it also changes the risk profile that the businesses have, and that they now need to, who owns that open source code? How do we know what we're putting out there? The open source code quickly becomes the majority of the overall code base, with up to 80 to 90% sometimes being of what you're shipping out the door being open source, as opposed to your custom proprietary code. The vulnerabilities present in open source code are known to the attackers because it's out there in the open source. And they have bots that are often constantly probing to find opportunities to take advantage of these vulnerabilities. Those kinds of vulnerabilities are much more likely to be found and exploited than a single hacker going at your private proprietary custom code. The vast majority of the 80% of the vulnerabilities, 80% is what we see in our scanning, are found to be indirect and transitive dependencies. So I'm including a library, and it's going to include a graph of other libraries that it depends on. And as you can imagine, that becomes very complex to try to scan and figure out where am I bringing a vulnerability in. Now, static analysis tools, SAST tools, we like to call them, are great at looking at your custom code, but they start to have problems in reporting false positives when you apply them to the massive open source libraries. They also take a long time to run. So they're good tools, but they often don't meet this challenge very well for iterative development needs. In addition, containers and Kubernetes are increasingly becoming the de facto way to package and run applications because they provide a standardized platform that can be built, deployed, and scaled in seconds. Containers bring a completely new domain of vulnerabilities, though, that developers haven't had to worry about before. Hundreds of Linux packages come in on these base images, and now these developers are being tasked to look for vulnerabilities there and understand what they mean. And finally, as we mentioned earlier, infrastructure as code, or IAC, this has enabled us to deploy things like networks, storage, compute, and all this stuff as fast as code. But as the NSA has reported, the number one vulnerability they see in cloud is IAC misconfiguration. So a successful strategy is to first focus on eliminating vulnerabilities in the open source code and to prioritize solutions that are effective in finding and fixing those issues. Sorry, get my slide to build here. SaaS solutions still need to be a part of the solution, but it needs to work with developers to scale. And it can work faster if it's only having to scan that 10 to 20% that's actually your code. Now we get to the slide I thought it was coming up, DevOps, so DevSecOps. So much like DevOps empowered the continuous delivery revolution by putting operations processes into code, DevSecOps is going to require the adoption of frictionless and intuitive security solutions to keep the same pace. The solution can't just be to report about the vulnerabilities. It has to be embedded into the developer's workflow and assist with education about the issues and how to fix them, automating these fixes whenever and wherever possible. The solution also needs to be backed by a complete, timely, and accurate vulnerability database. So this is where Snyk comes in. So as an advanced technology partner within the AWS Partner Network, Snyk has been able to has been technically validated to work seamlessly with AWS services. We've earned AWS DevOps competency and 2 service-ready designations for AWS Lambda and Amazon Linux 2. Snyk's also a private offer-enabled seller in the AWS marketplace. This allows your customers to use their existing billing mechanisms within AWS to purchase Snyk software, while also burning down their own committed spend with AWS, sometimes called their Enterprise Discount Program or EDP budget. Snyk is also a contributor to AWS Quick Starts, and I'll show you those. We got a few of those in a minute. This allows you to build automated reference deployments to help folks get their hands on and experience Snyk software using AWS best practice for security and high availability. We have 3 of those out there right now, and I'll show you those in a minute. Okay, so Snyk shares a multitude of integrations with AWS services along the application lifecycle, helping customers secure their applications from the developer workstation, which is like the coding block on this slide, all the way to production on the far right. Snyk open source integrates across the AWS toolset, including support for AWS Lambda, code commit, and code build to automatically, continuously find and fix application vulnerabilities in code repositories and serverless Lambda functions. Snyk Container empowers developers to easily find and fix vulnerabilities in container images while accelerating the delivery of your cloud-native applications. Snyk will automatically detect vulnerabilities in registries, such as Amazon's ECR, and can monitor Kubernetes clusters like EKS for new vulnerabilities and misconfigurations to protect the application after deployment. Snyk IAC, or infrastructure as code, helps developers find and fix security issues in their Terraform and Kubernetes files. So If you happen to be purchasing Snyk via the AWS marketplace, Snyk IAC can be purchased as an add-on to the products as part of the same private offer contract. The Snyk Intel vulnerability database. So this is kind of what I was talking about before, having a timely and comprehensive database of vulnerabilities. We have an entire team dedicated to keeping this up to date. It's the most comprehensive in the market. It is the most comprehensive and timely compared to most public sources or competing solutions, thanks to our community and that dedicated research team. It contains more unique vulnerabilities, gets them faster, and is accurate and actionable because that team doesn't just find the vulnerabilities; they also put in actionable fixes or advice and other metadata for developer remediation, helping the developers understand what to do to fix these things. We, as you can see, all the icons we have on this slide, we're a recognized CVE numbering authority, and we're trusted by several industry partners we actually provide the database for several of these companies to use instead of them building their own. So let's get back to developer first. So Snyk, if you see any of our ads, we're always talking about being developer first. One of the ways we aid developers and help them to figure out how to fix vulnerabilities that we find in their app is through prioritization. So as a developer, as I'm looking at vulnerabilities, they tend to pile up into what eventually becomes, an overwhelming backlog. So figuring out what to fix first and what's the most highest impact to me is critical. And we offer, for instance, scores. So you can see here on this slide, you have a Apache HTTP client vulnerability that has a score of 673. That's made up of various variables, including the CVSS score. Is this a mature, the maturity level of this vulnerability? Does it have exploits in the wild? Does it have a fix already available that you could just upgrade and fix immediately? So we provide a broad range of tools like this to help you get the context, the deep context of how to figure out what to fix now, what to fix then, and what is the impact of these vulnerabilities on your code. And as a developer, that's great because I'm not necessarily a security expert, but these tools, the people who write the content for these tools are, and they help you maximize the value of your time and strengthen the collaboration with the security team. Next, automation. I mentioned that earlier. When vulnerabilities are discovered, we present them in a clear way so the developers know not only what the vulnerable packages are, but also how they were introduced. So what's bringing this thing in and what needs to be done to fix them. In this example, it's not enough to give the developer just a report on it. We actually, in this case, can help them with a fix PR. So you write through the tool, we can let you know, hey, I can create a pull request on your code base that will correct these vulnerabilities for you if you were to take it. So you pull that in, you review it through your team, you test your app, you do whatever you need to do, and you didn't have to go figure out what versions of each software did I need to upgrade to get there. We also have, there are cases where there are no upgrades to fix an issue. So our team will come up with patches that can be applied to mitigate the issue in your code base. Those also can be automated, and we can pull them in with a pull request. We're seeing up to 500,000 patches applied each month by our customers. Licensing. So in some tiers of our application, we offer license compliance checking, which is extremely important. And it's not something developers often look at as they decide to pull in a new library. You can set policy up to what our company wants, what your organization allows for licensing, keeping track of all that. We also have reporting tools. So over time, for instance, the lower left example here, you can see issues over time. How are the developers succeeding with this tool? Are we empowering them to reduce the number of issues we have? How long have we been exposed to certain issues? All sorts of things like that. We work throughout the development process. As I showed you on that slide before with all the boxes, in your standard software delivery pipeline, we like to try to push everything as far left as we can. But we do offer the same kind of scanning all throughout that pipeline. So finding application vulnerabilities, OS level container vulnerabilities, and Kubernetes configuration issues, as early as you can find them, but also later. So if as a developer, let's say I forgot to check my Kubernetes YAML, we can offer that same exact scanning at your pull request or at your uh, source control level. We can monitor Kubernetes and see, oh, did you remember to not allow root on that pod? Things like that, which gets us into infrastructure as code. So the we scan today Terraform for AWS as well as Google and Azure, and Kubernetes along with Helm during development. So right on my desktop or right in my source control integration, I can see right away. In fact, we're seeing an example here that our source control integration is looking at a GitHub repository, and we see, oh, you've got a Docker file, you've got Kubernetes YAML, it's a JSON, it's a Node.js app, and you've got Terraform in there. So all of those things have come up, and we've found some level of vulnerabilities at just about every layer. You can go in and look at that and remediate them as your team sees fit. The tools are meant, as I said earlier, to be developer friendly at the outset. So if I'm looking, for instance, at this on the right, we've got a privileged pod problem where somebody has actually said, make this pod be privileged, which is bad. You want to do that. Why is that bad? Well, the overview we're showing here says this is why. If we were to have a full screen here, we could go into, looking into, well, what do I need to do? And in this case, it's obvious. Don't set that to true, so it's false. Finally, let's go back for a second to that static analysis, static applications security testing, SAST as the industry likes to call it. We have a new product that's coming out. It's in beta now. It's about to be released that takes that tool, which generally traditional SaaS tools end up at the end of your pipeline or far down on it because they take forever to run. They usually take hours to run, and it's one of these pipeline, pull the cord, stop the assembly line kind of things when they have problems. That's not dev friendly, really. What we've done is the product we're releasing, Snyk code, integrates right into the developer desktop, right into their IDE and their command line tools to give a dev friendly, actionable fix recommendation in real time as they're working on their code. It's 10 to 50 times faster than traditional SaaS solutions. And it's also powered by machine learning and AI algorithms that learn over time, and not just from your code, from the world's code. So it's looking at open source libraries, it's looking at all sorts of things, and it's training and learning how to better catch paths through your code for looking for security issues. Now, as I mentioned earlier, Snyk is a private offer-enabled seller in the AWS marketplace, meaning you can negotiate your custom pricing with Snyk and then fulfill the contract using your existing billing mechanisms in AWS. In most cases, this will allow you to burn down any committed spend you might have in that enterprise discount program budget. Purchasing Snyk via the AWS marketplace makes procurement quick and effortless, and for you and the Snyk team, cutting a lot of the red tape you would have had to deal with your legal and procurement departments, and helping you accelerate the time to value by shrinking the procurement process down to less than a week. Once you've negotiated your annual pricing with Snyk, we build the private offer in the AWS marketplace and let you know once the offer is live. At that point, you can just log into your AWS console, navigate to Snyk's listing, and click subscribe. It's pretty easy. AWS will invoice you for the purchase, and using the same portal tools you'd use for any other transaction, you're able to start using it right away. It's also enabled for consulting partner private offers, as well as solution provider private offers, allowing you to purchase Snyk software from your preferred consulting or SI vendor, and also using the same billing mechanisms that you'd use to purchase and deploy your AWS services. And finally, we have our quick starts. So I mentioned these earlier. These are free. If you go to the quick start page, just put in Snyk, and these three will come up. These are the three we have right now. We have Snyk Security, Controller, and Serverless CI/CD. So security is the open source scanning security that helps you search your containers and in ECR along with AWS Lambda and things like that. The controller, this is the EKS monitor. This is the piece that as you deploy software into Kubernetes, it will watch for configuration known issues that usually are going to be a problem for you, as well as look for base image vulnerabilities in any images that are being deployed as part of that workflow. And finally, the CI/CD starts up an environment in AWS Cloud with a full CI/CD pipeline, an example one using all best practices. So you can take a look at that. And with that, thank you for listening. Hopefully I wasn't talking too fast, trying to get through all that. But I'm ready to handle any question and answer or questions that you guys might have.
Well, that was actually really quick there. I had a little bit more time for you, but guess what? That just means we have more time for some questions. Don't worry about it. That's the fun of doing these events. So, real quick, before jumping into the questions, I kind of got a note that you mentioned Snyk has some quick starts, which you just shared there.
Mhm.
3 of them available, and the private offer available in AWS Marketplace. I'll recap that at the end of this one here in our closing remarks on some of the cool features with that one. I actually like the quick starts and having them available. So thanks for sharing that information.
No problem.
All right, let's jump into the questions, Eric. I put together 1 or 2, but I got a couple from the audience. I'm going to ask theirs first, and if we have time for mine, we'll get to mine. One of the questions is, how do you run Snyk? Locally as a developer, or do you consume it as a SaaS and integrate it into your pipeline?
So that's great questions. Snyk has a SaaS service behind it, but the tools themselves are a combination. So there's the CLI that your developers would use right on their desktop. We actually have embedded right into Docker Desktop if you're doing container scanning and you use the Docker Desktop app on Mac or Windows. We're embedded right into that. If you just do Docker scan, you don't have to install anything really other than Docker, and we'll start container scanning for you. But all of the different things you've seen scanned here, aside from the Kubernetes runtime monitoring piece, are all available through the Snyk tool, which is a free download. It connects to our SaaS service to get access to the vulnerability database, but it all runs locally. If you're in a CI/CD environment, you can run that from your scripting environment, or if you're in a plugin-enabled CI system, we have some plugins for those. The other side of that, though, is we do have the web-based SaaS system, which primarily people use for scanning their source control repositories, like a GitHub repo or something, or their image registries like ECR. And that tool is pretty nice in that not only does it do that for you, of course it's nice, it also will monitor for you. So you can set it up to say, hey, scan this, and then by default, it will rescan that every day. So let's say today I checked in an application change that checks out perfectly, no vulnerabilities, everything's great. Tomorrow we'll scan it again, even if you don't make a change to it, or if the vulnerability database has been updated and we found a vulnerability in your code, we'll let you know. I have that happen quite a bit in I have lots of demonstrations for my DevRel demos, and I'll have something that I have like 5 vulnerabilities that I know how to fix for my demo, and then all of a sudden I'll get an email. It's like, hey, you now have 25, because some kind of package or open source library has all of a sudden a bunch of vulnerabilities were found in it. And I get an email. It says, hey, here they are. And oftentimes they'll say, do you want to fix them? And just click this and it takes you through an automated fix process.
Now, does that scan happen automatically, or is it a time or scheduled scan, or when it comes out, it's available, the scan just automatically is initiated from that? How does that work?
By default, it's a daily automatic. So if I say through the various means of creating what we call a Snyk project, I import my GitHub repository, for instance. By default, it'll scan again overnight, every night. You can reduce that to weekly if you don't want it to do every night, or you can say, don't do this, I don't want you to. For some, if you've got like a sandbox that you're not wanting scanned all the time. And what's kind of cool about it is both for the registry, for the images, Docker images, and for code, it's not having to re-pull your image every time, because we pull it, we scan it, and we produce our bill of materials. We know what's in your image now or in your source code at that revision, and we can quickly then apply a scan to it without having to pull it every time. So that's how we can do it so fast and do it every day for you.
Oh, nice, nice. I
Now, of
like
course, if
that.
you make a change, we'll scan that right away.
Oh, okay. Hey, that's a great. Before I ask the next question, you mentioned you have another like a beta product coming out or a next release. I was trying to take a couple of notes on that one. Can you just give me just a quick like 30 seconds? When is it being
Sure.
released? Is it released and where's it at?
Sure. So I think you're talking about Snyk code.
Yes.
If you watch our press releases, about a year ago, we bought a company called Deep Code, and they were producing this software, and we worked with them to make it mature. And we decided, let's just buy them and make this be Snyk code. It is in beta today. Unfortunately, I'm not in sales. I'm in DevRel, so I just know how to use the stuff. I don't know what the schedule is for releasing. I know it's going to be soon. It's going to be. I can't give a date. I'm not allowed. But it's going to be soon. It is in beta. There's tons of information at snyk.io. If you go to the product tab, there's a lot of information about it. If you are interested in being in on that beta, you can contact us through the little contact us tool at the bottom, and I'm sure somebody will get a hold of you. Be willing to talk to you about getting you in the beta if they can.
Listen, there's only like 1,000 of us here. You can tell us a little bit when it's going to be released. We won't tell anybody.
I wish I knew. I honestly don't on that one. They've been very close to the vest on release dates on that one. There's a lot of other things that are coming out. You might tease out of me, but that's not one of them.
That's all right. That's all right. No problem at all. Let me get to the next question here. What if a customer is running their repository in a private VPC? And to add on to that, how do you connect into that private VPC?
So we do have, I believe it's in our Pro and or Enterprise tiers, we have the ability to scan. This is the same problem that happens if you have an on-prem repository, right? We have ways, and I being in DevRel, I don't deal with that very often, but we do have capabilities to do that. We have a broker and a proxying system that can do it. We have, I don't want to go too far down the road of how it works because I don't want to lie to you. But if you go take a look on our product pages for the integrations, you'll see which ones we support. So if your source code repository is one of the supported ones, we can hook to that, even though it's behind a firewall or in a VPC. We have ways.
There's always ways to do that or everything. I appreciate that one. I'm going to jump to one of the last questions that I have here for you. Do you have a way to inject the Snyk results into the developer flow? So for instance, can you show badges on GitHub that were findings in a PR?
Yes. So if you were to look at a pull request where, let's say you're using GitHub Actions as your CI type solution. One of those actions could be the Snyk scan action, and it provides I'm going to forget the term for it. The output, you can output from Snyk in more than just text. You can output JSON. You can output, what is the name? There's a file format that GitHub, for instance, can read that populates the GitHub build security testing list, and it's escaping to me because I'm on live stream right now. But it'll bat right up, and the scanning looks just like would look just like if you were doing automated testing in your GitHub pipeline. It's like, hey, this failed. Here's why. Go look at the details, like that.
Gotcha.
I have a YouTube video where I did this like 2 months ago. So
the recorded ones, the live ones are always like, they forgot or escaped my mind. I got you on there. That's pretty good. By the way, nice shirt you're wearing. I've got my very own here. I actually really like the dog look. I mean,
I liked it. That's Patch the dog.
Yeah. I didn't even. You know what? That's what I should have asked. What his name is? Patch the dog. Okay. That'll be a quiz one time. I'm going to have to post that on Twitter. Do you know the name of this dog? And if you work for Snyk, you cannot answer.
I have another trivia question. Do you know what Snyk stands for?
You know what? I want to know because I've got a comment later for N2WS that I always make fun of myself, and it's a redundant comment. But no, I don't. I want to know.
So now you know.